Hey everyone, welcome to lesson 4. Today we're going to be working on transposes, traces, determinants. Honestly, I wanted to do inverses as well, but I didn't manage to actually go through and do inverses from scratch myself today, so we'll keep that for tomorrow. But as usual, I'm gonna try and show you my process during the learning and not just showing you the thing, right? Because for me here, I'm not just trying to teach you DS math. Honestly, I'm teaching myself as well or refreshing myself. The goal is to actually show you guys how to learn not just this, but anything for yourself, right? Uh, Keys to always foster curiosity. That's like the biggest thing. I'm gonna keep repeating that. Probably it's gonna become my motto, or some form of that is gonna become my motto. Uh, keep being curious. Keep looking up things. Learn by doing as much as possible. Tie that learning into something in a way that actually could translate to something you do on a day-to-day basis. Come back to it repeatedly. Just hang around, and while you're reading, stop and think. I feel like these are the biggest things. People like to pull out a textbook and start highlighting. It's not, I feel, that really helpful for actually learning it, or even remembering it, because I personally feel there's a difference between remembering and actually learning something. Um, so let's just dive into it. I'm gonna just go through a couple of these tabs before I get into it. Transposes and traces were actually fairly straightforward, so there wasn't much of a rabbit hole to fall down until I got to determinants, where in the task it says to do the determinant of a 3 by 3 matrix with just by hard coding it, which is totally doable. But like I said earlier in my earlier videos, the best way to learn is to, just push yourself a little bit harder than necessary. That way you learn better. So I decided to actually make a more generalized function that can go towards any square matrix, any shape, any sized square matrix, because obviously the you can't do the determinants for um, non-square matrices. So I just here's the page where I just pulled up my test cases. That's just another ChatGPT conversation, nothing important. Looked up what a transpose was. Honestly, there was really not much to be done there. Same thing with the trace. I know what it. Well, actually, I forgot what a trace was. I knew what a transpose was. I just kind of looked it up anyways. Um, just to make sure trace is only defined for a square matrix. I just double checked that. There's really nothing much there. So this is where we started getting interesting, was doing the determinants and stuff. So before I get into the rest of the rabbit hole I went down, let's just do the code for transposes and traces really quickly. Def transpose, we're gonna take a matrix, right? And we want to return this matrix. What's a transpose? It's very simple. You're just swapping the rows and columns. That's all a transpose is, right? So I just wanted to, the way I did it was I kind of redid the code for JVal from a couple of lessons ago, if you don't remember, which is given an index, just get the actual column, right? So let's just do get call. I'm gonna call it that. Just call J and Matt, right? And always remember, while I'm coding, I'm kind of doing this from memory because I already just did this myself. But if I was you, I'd always like every couple of lines of code just test it, especially when you're in a Jupyter notebook the way I'm doing it. It's super easy and just keeps getting that instant feedback to make sure you're on the right path. Um, so anyways, get call JMat. So if we want to get take we want to get the column, right? So we want to return vj for v and mat, right? Yeah, so given a matrix, it'll have an index, or a column index as I like to call it. um, I just like using the letter J because I and J are common ways of denoting indices in matrices. Yeah, that's the correct word. Um, and so I just use J here. So I'm going through each row in the matrix mat, and I'm getting the jth element in that row, and I'm creating a new list which I'm returning, calling it get call. Okay, so just return that. That's a fairly straightforward process. Transpose, so um, remember there's not much to, if I remember correctly, I'm just gonna double check really quickly. Yeah, okay, I didn't, there isn't a there isn't an operation where transposes aren't defined, so I don't think there's any value errors or things like that that we need to keep in mind. So just moving forward, um, I'm gonna do. Actually, today, you know what? I'm just gonna kill it on transposes and traces. We'll make a really short video. Um, just call it that because I feel like determinants. I just did it earlier today, and just going back to the point of spaced repetition, I feel like getting a little more distance from it might be good for me to like cement the. Well, I know how to do determinants, but it was like kind of nice to actually go over it, and I feel like it's there in my brain really good. And if I feel like if I do it again tomorrow, that'll really help me cement it. Even though I kind of have to do determinants for inverses anyway, so you know what, we'll get to determinants tomorrow. We'll make that the video for tomorrow. Today we'll just make it a super simple, super chill. We're just gonna do transposes and traces. So for transposes, we're gonna do, let's see, what do we got? We got a matrix, right? We wanna take each row and turn that into a column, right? Um, what's the easiest way to do that? So let's go for J and not len mat 0. Well, let's do that range. Okay. T underscore mat dot append get call. Oh wait. Oh wait, no, that's fine. Get call J comma mat. Return mat. Oh, not mat. T underscore mat or transposed mat. That's just what I'm gonna call it. Let's just run this cell really quickly. I'm just gonna copy my asserts from over here, just because I'm being lazy, right? One thing I will point out, or I will just be careful when you're doing math stuff. Ooh. What's going on? How is it not defined? Oh, because I misspelled transpose, that's why. There you go, the assert's passed. Our transpose code is absolutely fine. We're just iterating through J, getting the column with my get call function, appending it to a new list, and that's our matrix, right? Try and do these things. You should do these things with NumPy, but honestly, with NumPy, these things are very trivial to do. So just learning NumPy doesn't necessarily, key into the actual key into the actual refreshing of the math. So it's just nice to do these by hand, which is why I'm going through this exercise myself and taking all of you along for the journey. Hopefully you guys learned something, and honestly, the most important thing that anyone who sees any of these, if anyone ever does, is to say that they learned how to learn. As you can tell, it's the name of the series. So let's move on to traces. So a trace of a mat. Okay. I think traces are only defined for square matrices. We already looked that up. We know that. So if I colon equals, called I max, because I think I'm pretty sure we're going to have to do a loop later. Colon equals, I'm just going to use the Walrus operator because I don't want to assign it again later. Len mat not equals len mat 0. Now, if you guys are eagle-eyed, you might remember that a couple less videos ago, I actually created a little function that actually went through all the rows and made sure they were the same length, because these are lists and not NumPy arrays where that kind of stuff is pre-enforced. I'm just not gonna do that here because it's kind of a trivial thing. Um, to do. I could have done it here again, but like today I wanted to get to the determinants because I felt like that was the meat and potatoes, and I'm skipping it today. I'm sorry. That's mostly a selfish thing because I want to go over it again tomorrow. Because honestly, it was also kind of fun. It really was. Um, yeah, so that's that. I'm not gonna do that here, though. Obviously, if you're doing this at home, change it up, turn around. Whenever you get doing any exercises, if anyone's ever handed you an exercise and you do just to the letter what they've exactly said, that's actually the right thing to do for if you're getting a grade for this, like in school or something. But weirdly enough, I personally believe that's not the best way to learn. Going off script is the best way to learn. So, add stuff, remove stuff, do whatever, like the pylons, type hinting stuff that I kind of abandoned after the first episode. I only did that in the first episode because dot products are so like basic and I just wanted like some way to challenge myself. But then after a while, I started getting annoyed with my pylon server. As you guys remembered, I'm pretty sure I just turned it off in lesson 2, if I recall correctly. Maybe it was lesson 3, I'm not sure. So anyways, if Imax does not equal, if basically the number of rows and number of columns don't equal each other, I'm going to raise a value error and say not a square matrix, right? Because this is only defined for square matrices. Now for I in I underscore max, because what is, sorry, not Imax, in range Imax, right? What is a trace? A trace is just simply the sum of the diagonals. So all we're really going to do is define trace equals 0. Tr equals plus equals mat I. That's really about it. And return trace. Now, one thing, I'll be brutally honest with you guys. I'm gonna show you how I did this originally, and I feel super stupid for it. So I'm just gonna go ahead and show that. So when I did this myself, I have like the notebook here, but I'm not gonna show you in the notebook. I'll just show you here. I actually separated out Imax and Jmax. Remember, I and J come from like the common terms for indices in a matrix. I just call it Jmax because I'm gonna iterate it, and I wanted to use just I when I'm actually doing the iteration. I did it like this, j underscore max colon equals this. And then instead of doing this, I did another one for j in range j underscore max colon. And then I went another layer deep. If I equals j, then I would go gr plus equals mat ij. But that's completely unnecessary because obviously like it's the diagonals, like the indices will be the same, so it's just you're just adding an extra loop for no reason, so that was completely unnecessary. Trace I captain. Are you ready, kids? No. A little SpongeBobbiness for you. Just gonna do these trace asserts. Now, I'm not like actually manually checking each of these like on the video. Oh yeah, because trace doesn't exist. Let me just do that. And all of our asserts pass. Now, I'm not manually checking these in the video because these are ChatGPT generated. But when I'm doing this by myself, like before I actually make these videos, I always like, maybe not literally all of them if there's a bunch, but I will check a few. And if it becomes a hairy calculation, like with the determinants, when you're going for larger matrices, I just use a determinant calculator online. So make sure to double check those because sometimes things are wrong. Like a little sneak peek for the determinant video, like I generated a bunch of test cases, and like the ones for the 3x3 matrices were fine, but then when I asked it to generate more for 4x4 and 5x5 matrices, and and like I would get a bunch of assertion errors, and I was like, wait, what? And at Initially, there were some bugs and I fixed those. But then after I fixed all the bugs and I like double checked my code, I'm like, no, this is absolutely perfect. And I just start punching it into a determinant calculator because I didn't want to do a 4x4 and a 5x5 matrix determinant by hand. And it turns out that ChatGPT just gave me the wrong answers because, who knew probabilistic text generation isn't actually good in math? Oh no. Something that like the reasoning models kind of sidestep by just giving the LLM a coding tool. Because if I switch to O4 Mini High, instead of trying to just generate text, it just pulls up like a little, it spins up its own container and just writes some code and gets me the answer that way. Yeah, so that's a little fun thing. Like, whenever you're using like these AI tools and stuff, and I'm clearly using them quite a lot because I kind of generated this course from scratch for myself, like using this because it was just the most funnest thing for me to do. Be careful, don't like 100% trust them. They're not going to be perfect. And especially when you're starting off, try like, okay, you can use it to like look up something, but then like constantly be questioning it, like, okay, and not like questioning it by like texting it back and asking it, but like literally go rogue and look up things online. Like, in fact, when I was doing the matrix multiplication stuff, I think, let me see if I can find that. I'm actually going to just show this. Let me see if I can find it. Matrix multiplication rule. I think it was here. Yeah, it was this one. So here it tells me that a 2 by 3 by 3 by 2 is valid, but 3 by 2 and 2 by 3 is not valid. Except that's wrong, because in both cases, the number of columns in A and the number of rows in B are matching. So this is like just plainly false, and it didn't make any sense. I'm like, huh? So be careful. That's all I'm saying. Anyways, thank you all nobody right now, but thank you guys, regardless, for maybe the future views that might come someday, for checking this out, and I'll see you guys tomorrow. Have a great one.